So on Friday we talked about just the basics of 3D shapes. Today we're going to talk about specifically prisms and cylinders and how to find surface area and volume. So before we do any of the formulas, we got to get into detail about what a prism is. So if you remember, by definition, a prism has bases that are congruent faces in parallel planes. So in this picture, we have the bases being these two hexagons, and they are parallel planes. What's around it are those rectangles that make it a prism. Faces that are not bases are called lateral faces because they are just lateral on the sides, and they're also faces. These faces intersect at, you guessed it, lateral edges. The segment that is perpendicular to the base is called an altitude, which is a height, which you should know that word from before. If the lateral edges are also altitudes, meaning all these little edges here are perpendicular to the base, it's called a right prism because it sits upright. If they're not perpendicular and it's kind of slanted, it's called oblique. And that's an example here of an oblique prism. We are going to be finding surface area and volume of all different kinds of prisms, whether they be right, oblique, and have different bases on them. So, surface area. By definition, surface area is just the area around the 3D solid. Think about the amount of paper it would take to wrap the solid. So at Christmas time, at someone's birthday, you're giving them a gift, something, and you're wrapping it up in paper. The paper it takes to go around this prism and the top and the bottom to completely cover it. That's your surface area. For our prism, there's a formula. T is represent surface area because it's really total area is what the T stands for. Is capital P lowercase h plus 2 capital B. There is a reason for a capital P and a capital B because of what they represent. Anytime you have a capital letter, it is talking about the base of the figure. P, like always, represents perimeter, but it's only the perimeter of the base. So that would be the perimeter of this hexagon, not these rectangles. H is your height of your prism. So from the base to the base, how high is it? And then capital B is the area of that hexagon, the area of the base. So be careful because like if we have triangles, a triangle itself has a height and a base, but those are not the same heights and bases we are talking about with total area. We are talking about the height of the prism and the area of the base. So the area of the triangle would be that capital B, not the base side. That's a little b. So to start off, we're going to do some examples. The first one being a rectangular prism labeled 3, 4, 12. The perimeter of the base is 14. I use this piece right here to be the base. So 4 and 4 is 8. 3 and 3, 6. 8 and 6 give me 14. That would make this other number, the height, which is 12. The area of the base is 3 times 4, or 12. So then that means in my formula, I have 14 times 12 plus 2 times 12, or 192. The great thing about rectangular prisms is I didn't have to let this front side be my base. I could let the bottom, the 4 by 12, be the base, and this 3 be the height. In that scenario, I'll show you that you still get the same area. If you let the 4 by 12 be the base, the perimeter would be 12 and 12, which is 24, plus 4 and 4, which is 8. So 24 plus 8 is 32. That would make my height now 3, and the area of my base 48. If I were to plug that into my formula, 32 times 3 plus 2 times 48, you still get 192. So with a rectangular prism, it doesn't matter which rectangle is the base. It only matters when we have non-rectangular bases. So in the number 2, the base is a triangle. If you notice on your paper, you have 2 here, 3, and 4. This 5 is not here. This 5 was found by using the Pythagorean theorem. The Pythagorean theorem is a great tool to have in your pocket anytime a triangle is involved. So keep that a squared plus b squared equals c squared in your mind. Then, because this is a triangular prism, that means this triangle is my base. The perimeter, 5, 4, and 3, is 12. The height of my prism is 2. And the area of a triangle is 1/2 base times height. So that's 1/2 of 4 times 3, which is 6. Plug it in my formula. I get 36. Now pause the video and take a few moments to try the you try. On the you try, hopefully you are able to find all the parts. Here, again, the triangle is the base. So the perimeter would be 15. The height of the prism is this other number over here, 10. And the area of the triangle is 1/2 of 4 times 5. So our surface area, or our total area for this triangular prism, is 170. Next, we're going to talk about volume. Volume is nothing more than the space that the figure encloses. So how much space does it fill up? If I was filling this box up with sand, how much sand would take to fill it up? If water, whatever. The formula for a prism is area of the base times the height. Basically length times width times height, which is what you're used to hearing. We just like to shorten it up a little bit and say the area of the base times the height. So again, you are looking at what's the base, what's the height, plug it in. So in example 3, we have two triangular prisms. This is the one from before, and this is the one from before. We just labeled them the same way. The area of this triangle, remember, is 1/2 base times height. So in that case, this would be 10. And that would make my volume 100. I have no idea where the 6 came from. I apologize for that. In this case, the area of the base is 6 times the height, which is 2. So 12 would be your volume. So area of the base times the height. If you have any questions about prisms, please ask Miss Lewis now. Next, we're going to talk about cylinders. Cylinders are very similar to prisms in their formulas. The only difference is with a cylinder, your base is always a circle. So you have to take into account the area of a circle, the perimeter, quote unquote, of a circle. The first definition is an axis. An axis of the cylinder goes from the center of the circle to the other center of the circle. So from here down here, that's your axis. And from here to here is an axis. If the axis is in altitude, meaning it's perpendicular, that means it's a right cylinder because it stands upright. But if it's not, then it's oblique and it's kind of sideways again. So remember that oblique is sideways, and you have to draw out a perpendicular line over here to actually see what the height is. Because in this case, this length is longer than the actual height of our cylinder. Now with surface area, remember for a prism, it's the perimeter of the base times the height plus 2 times the area of the base. Well, if you remember from our circles unit, perimeter of a circle is really circumference, and area of a circle is just an area of a circle. So if we take that into account with our formula, surface area, or T, is 2 pi RH, because this is circumference, plus 2 pi r squared, because this is our area formula. So anytime a circle as a base is involved, you're going to have pi's and r's and squares and 2's and all those fun things. So again, surface area of a cylinder is 2 pi RH plus 2 pi r squared. It's 2 again because there are two bases, so we have to take into account both of them. So then we have a couple cylinders to look at, and I just wrote these with respect to pi. You are more than welcome to write them in decimal form. It will tell you how to round on a test or a quiz, or it'll say leave it in pi form. So looking at this first cylinder, my height is 6, my radius is 4, so plugging in my formula, 2 pi r being 4, h being 6, plus 2 pi r4 squared. 2 times 4 times 6 is 48. 2 times 16 is 32. These are like terms because they both have a pi, so that's 80 pi. If you were to type it in your calculator, type this in exactly as you see it using the pi button, and you would get a decimal number of 251.33 when you round, which is the same as 80 pi. The one on the right, just the cylinder has turned sideways. It's still a right cylinder. It's still nice and pretty and not slanted. And you have decimals for your height and your radius. Doesn't change anything. Still plug it in your formula. Combine my like terms is what I did there. So I got 92.66 pi. Or if you plug the whole problem in the calculator, you would get 291.099 and some change. Next, the volume of a cylinder, very similar to a prism. It's the area of the base times the height. Area of the base is a circle, so that would be pi r squared. So this is just pi r squared h. So looking at our two problems that we have, you have this being 10, but this piece being 20. You use the Pythagorean theorem because it's a right prism to find that this is the square root of 300. Plug it in your calculator and you get 1360.35. In the next one, you are given 4 and 5. Well, if you remember your Pythagorean triples, that means this has to be 3. And remember, pictures are never drawn to scale. So even though this looks longer than that, this 3 is still 3. Plug it in your formula, you get 12 pi or 37.699 and some change. With these types of figures, remember again, Pythagorean theorem is your best friend. If you have any questions on cylinders, please ask Miss Lewis now. Otherwise, your assignment is the worksheet questions 1 through 10 going through and practicing surface area and volume of prisms and cylinders. You have a quiz tomorrow, so please make sure you learn these formulas and study.